will present your work, okay, about Tidal. Okay, you may start when you're ready.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Kami daripada studio akan menceritakan pasal Tidal. Seperti my name is Muhammad Syarafli Mahalik. Number matematik nama is AN 2201014. For our group, we from Tidal. Tidal energy source is renewable energy powered by natural rise and fall of ocean tide and current. For this Tidal is very safety for environment because Tidal use natural being use of the natural rise and fall of our sea, ocean tide. Yes. And the distribution, tidal energy is power produced by the surge of ocean water during the rise and fall of tides. Tidal energy is a renewable source of energy.
Okay.
So,
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Ahmad Irawan. My metric number is AN220089. Okay, I will present about advantage of tidal energy. First, it is easy to predict the tides. The second one is tidal turbine are 80% efficient than other renewable energy. Okay, and third, high energy density than other renewable energy form. And for disadvantage, the initial construction cost is very high. The second one, it effect on animal and plants living near tidal energy. For example, we have Tasikenya that maybe harm other animal and plant at Terengganu. And the third one is it produce power for only about 10 hours of a day.
Because of Tidal.
Because of tidal.
Okay. Why it's very expensive, costly?
Because when we construct the dam, we have to try the place first, and then we make the dam and put the generator, motor, and everything else.
And also because of the tidal movement as well.
Yes.
Okay. It's a very high kinetic energy. So it's not like a lake that the water is calm. So makes the process also a bit dangerous. Okay. Alright, proceed.
Next, my name is Muhammad Shafiq Aziz Zaini. My metric number is CN220442. Today I would like to explain about the flow of this project. Firstly, this one is dam. The turbine connected to gearbox that turns a generator to create electric. Then we go to step up transformer. It will distribute to it will go to transmission line 132 kV or 275. Then it goes step down, and this one will go to distribution. Once it go to distribution, it will distribute to industrial area, commercial and residential. For industrial area, 11 kV, 11 kilovolt. For commercial and residential, for 3-phase is 450, and for single phase residential is 240.
Can you explain more about the concept of the tidal itself, tidal energy? Can you demo?
Oh, demo. Once the water level Okay, sorry. The minimum height for Tidal is 5 meter.
Okay.
For the minimum. And from my research, in South Korea or France, they will make once the turbine generates about 240 gigawatt. No, megawatt in single day.
Okay.
In one day.
What else do you want to demo?
So once the turbine is on, the water level will so,
Alright, friends can support.
Because of the different level of high of tide, the pressure from the tide will flow the turbine
Okay.
to produce the energy from the turbine.
Okay. So, like a tidal, right? You will have to move two different way, right? Two different direction. Okay. Once when the tides up towards the shore, and the second one will start to move back into the ocean. Okay. So will your alternator or generator able to, how is going to make use this opportunity to produce the electricity? Bagaimana? One directs to here and the other one directs to the other location. So you punya generator one way ataupun two ways. Two ways macam mana konsep? One way. So sekali pusing saja. Tak cukup lah tu. It's normally in two ways, right? So it make use could be flapping device in which when it sends automatically sends the direction or the force of the direction of the tidal itself. Okay, maybe during this direction, and it's actually move towards that direction. Okay, then the fan is moving. Okay, right. So when it returns back, and then it automatically move on different direction. Okay, or both static at the same position. However, the different rotational that can be
forward and
altered
reverse.
by using the gearbox. Whatever the direction will come out as a single direction. That could be another way, right? But normally you just have a free way to 180 degree to make use the both of the direction. So the producing of the voltage and the producing of the power can be, say, will make use the whole duration of the tidal as well. So maybe you can emphasize more, detailing more in your report. Yeah. So and then make use information about the real construction or the real function, okay, or operational of types of the generators that you are using in the report as well. Or maybe when you represent recorded version, you can re-explain again and just a little bit detail, and also to show there could be any real application could be in YouTube's, okay, of the short videos and so on. Okay, one thing that I would like to comment is about the overall model of your project, where actually the termination from the generator to the transformer? Where is it?
From my research, from this generator, we have underground cable to transform.
That one should be under sea, or that one should be underwater cable. Okay, you need to show whether in virtually it's connected, could be in parallel, and then goes into the substation, and then that got the substation with the step up transformer, and then you labeling this as a main transmission line with the specific voltage and also power output, and that goes into the first, I'm not calling step down, I'm calling as a pencawang masuk utama. Inside it got the transformer step down. Okay, and make use this as well in your model. Okay, so connect it to the second transmission line and connect it to the distribution. Okay, and then you may parallel it to the third distribution. That one may be down to 11 kV or 33 kV. One straight into the distribution also need to be. What do you mean by distribution and industrial area? That would be cawang masuk utama. Maybe you can put it here and then step down next to it, PMU, which got all the switching circuit breakers and so on. Then goes to industrial, okay, 33 kV for instance. Okay, and then after that goes to the commercial. Must have another small substation or step down transformer, 33 to 11 kV, and then maybe from 11 kV underground cable goes to commercial. So down 11 kV, make use 6.6 kV for instance, or still another 11 kV also can, and then that one 11 kV down to 415. Right, so I hope that you can improve your model to indicate those in details, and maybe you can represent again during the recorded version. Okay, looking forward to that. Alright, well done. Okay, that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adi Ramza bin Azhar. So I will present about software part in our project. So in our software we have a few parts, which is consists of, first is project initialization, which is we using PSCAD to create our circuit. After that we do a simulation parameter setup. It configures simulation parameters including start time, end time, and time step through the project option. After that, we component selection and placement. We utilize the PSCAD library to select and drag relevant component onto the workspace within the power system topology. After that, it also contains a component configuration. Next, system interconnection, grounding specification, simulation type selection. For simulation type selection, we choose the simulation type or frequency domain based on the specific study requirement. After that, we put the initial condition setting into our component. After that, we do the simulation execution, which is we execute the simulation by clicking the run button and monitor progress. After that, we do the result analysis. After we get the result, we do the analysis, which is we analyze simulation result including waveform, phasors, and other parameters using visualization tools provided by PSCAD. After we analyze, then we do the troubleshooting and optimization. We modify system parameter component as needed to troubleshoot issues or optimize the system performance. After we done all the process, then we save the project. We save project to preserve the work and documented simulation setup, assumption and key result for future.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Iskandar bin Zaidi. My metric number CN220159. So I will explain about our simulation by using Pascal. So this is our circuit in the software. We use single phase as a source. So this is our circuit, and our power factor in this circuit, we use 0.75 because our tidal, when the energy convert to the electric, we get like 0.75 the power factor for the power factor. So we get the phase angle is about 41.41 degree. So we do some calculation, and the calculation we get resistance, capacitance for sending, and we get resistance and capacitance for sending. So resistance and capacitance for receive. For receive, we get 99.59 ohm and 0.234 H for capacitor, and for this sending resistance, we get 6 ohm and 0.053 H for capacitor. So these are our circuit. So in the next slide is about our graph in the simulation about our project Tidal. So for VS and IS, so this is our graph. It's about we get the maximum is 190 something, and for IS is about 1.3 kilo ampere for IS, and for VS RMS, so this the graph for VS RMS and IS RMS, and we also have a P set and Q set. And the last slide is about graph about receive graph receiving. So this is our VR and IR graph is about 20 kilovolt, and I is same 1.32 something kilo ohm kilo ampere, and this is our VR RMS and IR RMS, and we also get the graph PR and QR. So this is our simulation about this our project. Thank you.